Hi, my name is Princess and I'm your tutor for today. So today we are going to do a brief review or brief overview of machine learning. Um, Today's plan is simple. We are going to go over introduction to machine learning, learn types of machine learning problems and algorithms, and linear regression. So machine learning is a revolutionary field of artificial intelligence that enables computers to learn from data and make predictions or decisions without explicit programming. And this results in better decision based on the experiences which the machine has gathered over time. Let me give an instance. You have an ordinary system, and this ordinary system merges with artificial intelligence, and which then machine begins to learn. What happens is that the machine learns. The machine is able to predict based on what it has learned over time, and the machine improves the system over time. We have various machine learning processes. We have data collection, which is the first process. In data collection, it is the starting point of every machine learning process. You gather a large amount of data set, which you want to use for the machine to learn from this data set. These data sets can go in form of email, that's like having a data set that has different types of emails, both spam and not spam. The next process is data preprocessing. In data preprocessing, every raw data that is gathered is messy and is noisy. When you have a raw data set, you have to clean the data set, you have to organize the data set, you have to transform the data set into a suitable format that the machine can understand. In this process, we check for missing values, we check for removing duplicates and trying to normalize the data. The next is the feature engineering. So in feature engineering, what we hope to achieve is to get those variables or those features that that is needed for our machine to actually give us the output we want. So in this process, the machine learning engineers or data scientists try to select the relevant features that will help the model to give the expected predictions, which will in turn give an improved performance of the model. The next step is the model selection. So when it comes to model selection, there are different types of machine learning problems, and there are different types of machine learning models or algorithms that are used to solve these particular problems. So you cannot go and use a classification algorithm to solve a regression algorithm or a clustering algorithm. So this is what the model selection is very important, because if you select the wrong model, you're going to get the wrong predictions. The next we have is model training. So here is where the machine actually starts learning using the model it has gotten. So it learns and learns and learns from the data it has to look for patterns, to look for any pointers that can give it idea of what is happening in the data. After the model finished training, the next step is to evaluate how well the model has trained. Did the model train well? Did it predict what it's actually supposed to predict? There are different types of evaluation. We can use the F1 score, the mean score, the recall, the precision. Those are types of ways, or the ways we can evaluate a particular model. The next we have is the hyperparameter tuning. Like I said before, what our goal is to actually have a model that will have the best performance. So you have to tune these hyperparameters, fine-tune them, make sure that experiment with different parameters to make sure that what we are getting at the end of the day is a very good performing model. Then the next thing you do is to deploy. Once you have a good performing model, the next thing to do is to deploy it into a real-world application. It could be integrating it in a website, it could be a model application, an automated system, depending on the use case. Now, we have different types of machine learning. We have the supervised learning, we have the unsupervised learning, and we have the reinforcement learning. So when it comes to supervised learning, the machine learns from training the labeled dataset, a labeled dataset. Unsupervised learning, the machine learns from training an unlabeled dataset. Then from reinforcement learning, no dataset is given to the machine tries to learn on its own. Now, when it comes to supervised learning, like I said, here the machine has a dataset, a known dataset, a labeled dataset. So here you can see that this machine has pictures of what a mouse looks like, and it is the machine is labeled as a mouse. So when it goes through the training model, the machine is able to see that, okay, anything that has these types of features is going to be labeled as a mouse. So if we give it a new data, which has the features of a mouse, it's going to print it out as a mouse. So that is a brief illustration of how supervised learning looks like. Then when we talk about unsupervised learning, here it is giving an unlabeled data set. It's giving a lot of data. So here in the illustration, you can see it has mouse and it has keyboard. In an unsupervised learning, when you pass it through the training model, what it tends to do is to find a pattern. Which of this data in this data set have the same features? And what it does is actually group it into the two different features, or the features it can see. So you can see that these features, which are kind of rectangular, are keyboards, and they have the same features. So it groups them. And it can see here that the mouse too has the same features, and it groups them because they have the same features. The next slide is reinforcement learning. So in reinforcement learning, what it actually does is to give it, the best way to explain the reinforcement learning is, I'm going to use a hoover, an automated hoover. So you drop an automated hoover in a room and it goes around, it moves around the room. Now, the only instruction or the only thing this hoover knows how to do is to go left, right, front, and back. Now, it doesn't know where things are placed in the room. So it just goes, explores the room, and it knows that if it hits a table at a particular point, it's not going to go back to hit that table because it learns from the feedback it has gotten. So in reinforcement learning, we have the input, we have the response. So it has the input here. This is obviously a mouse. So the response it will give, because it actually doesn't know what that is. It doesn't know the features of a mouse. It's going to say, oh, it's a keyboard. And the feedback we give is that, no, it is wrong. It is a mouse. And it notes that feature and say, okay, based on this reinforced feedback I've gotten, it is now a mouse. When you give it a new data set. The next thing we have is machine learning problems. Now, like I said, we have 3 machine learning problems. We have the classification. So a classification problem is actually used when 2 outputs is required. Is it true or false? Is it yes or no? For the example I gave cancer diagnosis. Now, a cancer diagnosis only has 2 values. It's either it's malignant or it's benign. So the algorithms used for a classification algorithm is logistic regression, decision tree, random forest, XVM, KNN, and naive Bayes. Now, our next slide is clustering. Our next machine learning problem is clustering. This is used when the data needs to be grouped together based on their pattern. So, for instance, our example about the mouse and the keyboard, it is grouped together based on the patterns the system is noticing. So example I gave here is a news grouping based on the topic. The algorithms that can be used are the k-means, the hierarchical clustering, and the DBS scan. The next is a regression. Regression is used when we have continuous numerical value that needs to be predicted. A very good example is house prediction. So the algorithm used is linear regression. Now, this brings us to linear regression. Linear regression is used for modeling the relationship between a dependent variable, which is the target variable, and one or more independent variables, which using a linear equation. So I'm going to talk on dependent variable and independent variable. When we talk on independent variable, these are our target variable. So with the example of the house prediction, our target variable is the price, which is dependent on its own. So the independent variable there could be the location of the house, could be the measurement, the square feet of the house, could be how many bathrooms the house has. Does the house have air conditioning? Does the house have heating? So these are the independent variables. So the dependent variables are independent on those features. Now, here we have the linear equation, which is y is equal to mx plus p. Now, our y is our dependent variable, which is the target, and our x is our independent variable, which is the features. Then we have the slope, which is m of the line that goes through the y-intercept, and b is the y-intercept, which represents the value of y when x is 0. Now, linear regression is used to predict house prices, like I said, based on the square footage, number of bedrooms, and so on. So what is done is that it analyzes the relationship between the independent variables and the research outcome. So our example today is going to be on house price prediction. Now, we are just going to use our features from a house to actually get a price. So, like I said, the first step in a machine learning process is to collect data. Our data at this point is collected from Kaggle, and the link is below. The first thing you do is to import the needed packages. So where we have pandas is used to get the data frame. We have matplotlib and seaborn, which are used for visualization. Then from sklearn, we have the train, test, and split, which is used to divide our data into the training set, the testing set. We have a linear model, which is from sklearn to we import the linear regression model. Then you check the metrics for the evaluation, the mean squared error and the R2 score. The first thing you do, you load the data set. After loading the data set, we'll try to look at the first 5 rows to get a feel of how the data set looks like. Then you describe a little bit of statistics just to give you an idea of what you're working with. Then you check for null data sets. Remember, we are going to pre-process our data. We are going to check, is this data okay, or is it raw, or does it have duplicates? That's what we check here. Then the correlation matrix, this is to know the features which will help us detect our price better. After doing your correlation model, you see it. I'll show you in the next slide. Let me just show you. So in the next slide, you see the first 5 rows. From here, you can see it has the price, it has the area, it has the bedroom, bathroom, stories, and so on and so forth. Those are the features of that data set. And we'll use these features to actually, these features, the area, the bedrooms, and so on, we use it to predict the price. So given the fact that we have our correlation matrix now, price against price will always be 100%. Area against area, 100%. So, but from the price here, we see that the area is 54%, the bedroom is 37, the bathroom is 52, the stories are 42, and the parking is 38. So this gives us an idea of how many percent or what features are actually correlated to the price. And from here, we see the area, the bedroom, the bathroom, the story, and the parking. Then by the side here, you can also see that we do not have any null data, so the data set is good to go. So I'll go back here, and from here, you'll see, from here, you'll be able to see in the preprocessing aspect, we chose the area, the bathroom, the bedroom, the stories, and the parking. Then the Y, which is the target variable, is always the price. You can also see where we splitted the data, where the test set was 20% and what this does is that this training set, this is the training set where the model trains on that training set. After it has finished training, you can just use the testing set to evaluate the model. And linear regression is evaluated using mean square error, R square, and other evaluation metrics. But for this occasion, we're going to use these two. So this is our values for the mean squared error and the R squared. Gave over 54%, which is okay. In the predictions, you should actually have visualizations that can help you check, am I doing the right thing? So what we did here was to visualize a scatter plot, and our scatter plot, you can actually draw a straight line from this actual versus predicted, which gives us a really good prediction. Now we have our data or our model working very fine. We are showing it predicts well. What we did was to give it a new set of data to see how well it will predict. So the new set of data, the area, the number of bedrooms, and so on and so forth was given to it, and it predicted it. It predicted the price as this. So that shows that our model works very well. Do you have any questions? If no question, thank you very much.